Hello, good afternoon. My name is Shaohui, and I'm a PhD student from Eco Polytechnic de Federal Lausanne at EPFL in Lausanne, at Switzerland in Lausanne, sorry. I'm currently working on numerical methods for model predictive control and its application to robotics. So my joining of ELO-X is kind of accidental, let's say. So I have applied to a lot of PhD positions after my master's study. And among them, I think ELO-X was the best of them because there are many secondment and exchange opportunities and many seasonal schools and many visits around the world. So I like that really much. And besides, my supervisor was very good, so I chose that. In terms of speciality of ELO-X, I think speciality always come along with comparison. So if compared to other PhD programs at EPFL, it is kind of special because we have discountment and visiting opportunities. Because a normal PhD will only, let's say, go to conferences and that's it, publishing papers and that's it. But here you can go to a lot of places. But if compared to other, let's say, Marie Curie networks, there are also other European networks that focus on, let's say, one single project. And maybe some group focus on mechanical design, some focus on theoretical parts, some focus on other parts. But they are working on the same project, that's fine. But people within the same project can hardly understand between each other because if you do mathematics, you can hardly understand mechanics. But for us, we are all working on optimization learning and machine learning and control. So we have the same common language, so we can understand everything within our framework. So I think that's very special. Right. So I chose to be a PhD because during my master's study, I did a master's thesis on numerical solvers for a nonlinear MPC solver on the quadruped, which is a dog-like robot that working on the terrain. And I wrote a solver for that, I think, and I explored many like numerical tricks and numerical proofs for the solver to be working. I think it's very interesting. And before that, I worked on quadratures, the drones flying on the sky, and I also have some planning and trajectory optimization algorithms. I think that applying those, let's say, control and optimization techniques, and I see them really working on real hardware and whatever working on the ground or flying on the sky, I think it's very exciting. And that's why I chose to be a PhD. If I have the chance to choose again, I definitely will do the same because my professor was really fantastic and I have the biggest freedom to do whatever I like in research-wise and like let's say collaboration-wise or whatever-wise, and also I have these amazing ELO-X colleagues. So I think if you want to see the future of something, you need to go back first. So if we go back and we see that MPC is actually solving optimization, the core of MPC is solving optimization problems in real time, let's say. So in terms of optimization, we are all students of Lagrange, Euler, Pontryagin, and Bellman. In that sense, we are all students of them, and my point is that the building blocks of the theoretical foundations are still there, and it is quite unlikely to be changed in the future. So given that, let's say we are all trying to apply those theories to the reality. And with the advances, especially the recent advances like in numerical solvers and the highly computational powers, we can solve a lot of problems that cannot be solved in the past. But it's not because of theory, it's because of the powers, computational powers we have. So back to the question, so I'm hoping, or I think, there will be advances on numerical side of MPC, but those are not, the theory part is the application part. But I personally will not call it as breakthrough. It's only applications, but it's still something meaningful, of course. So maybe in the future, let's say 5 or 10 years of, let's say, given dynamics, dynamical system, whatever it is, whatever robotics or microgrid or whatever, you can do some formal analysis of the system itself, and then you formulate a good to solve optimization problem, and then you are good to go. I think that toolbox, let's say, can be expected in the future. I would like to emphasize more on similarities. So just like I have mentioned beforehand, this ELO-X project have the center focus on control optimization, machine learning, so that everybody is on the same page, professors included, of course. So the similarity comes on this side, I think. For the differences, yeah, there of course, people from different cultures, they thought differently, that's fine. And I really enjoy to talk with people with different minds, let's say, or minds, like, how to say that, different, exactly, different, yeah, different methods of critical thinking. So I really enjoy that communication. So before I started my PhD, I was once imagining to be a professor, but now that it's only 1.5 years, and I already feel that, okay, professor is not a good job for me because I'm not smart enough and I'm not good at selling my points to raise enough fundings, I sometimes think it might be a little hard or tough to always thinking about something new to research on. So now I would prefer to go to industry to do some like engineering jobs, because I came from the field of robotics, and I have shared with you that I like to have something hardware, have some hardware really working in the real applications. So I think I would like to be a robotics engineer in a control sense or in a planning sense. Like to help the robot to make smarter decisions. And to achieve that goal, I think I would like to to use my rest of my PhD to explore as many as possible different topics in robotics and in the field of control theory, so that when I go to the industry again, I probably will not have the chance to have the big chunk of time to learn these theories. So I would like to learn them beforehand now, and that's something I'm expecting.
Great. Can you give us
Mm-hmm.
some final thoughts on the ELO-X program and how it helped you develop yourself, maybe personally or professionally?
I think ELO-X really provides a fantastic platform for the early stage researchers to explore whatever they enjoy, and they provide the platform for collaborations and communication. I think the keyword is free. It's really free. Like there's no like fixed goal for like provided by the EU said you must do this, you must do that, and this is the takeaway. No, there's not. There's some soft deadlines, let's say, but they're soft, and the soft results in free. And I think for free is something like maybe one of the most key points of the researchers. Okay, that's it. Okay, thank you.